Alright, welcome class. Have you ever wondered how do these gravity-defying machines fly in the sky? That's why we're gonna learn about the principles of flight today. Today, here is this beautiful aircraft that I've, drawn for you guys today. There are 4 forces that act on every single aircraft. The first one is lift. Say it with me, class, lift. What is the opposite of lift, you may ask? What do you think it is? Maybe gravity? No, it's weight. Okay? And another force, how do we go forward? Well, we have thrust. Now, what is the opposite of thrust, you may ask? It is drag. Now, say it with me, class. Lift, weight, thrust, drag. So let's go over probably the most important one of them, lift. How do we keep this aircraft in the sky? Okay, the first thing to understand is the wing. This right here is what you would see the wing at a side view. If you were looking at the aircraft from the side, this is how you would see the wing. The first thing we gotta understand is terminology. So, this right here, the front of the wing, is called the leading edge. Now the behind of the wing is called the trailing edge. Now there's some imaginary line that connects these two together. And this is called the chord line. So, you're wondering, how does this have to do with lift? Well, I'll tell you right now. So, as wind travels over this wing, this is called relative wind. And between this relative wind and this chord line, we get an angle. If you need a better visualization because that doesn't make sense, I'll draw it out better for you. This is a flat version of it. Here comes this relative wind. It hits it right here. And you see how there's this angle right here? In between that is an angle. And that is called angle of attack. This is important because the greater angle of attack you have, the more lift you have. And that's important because that's what keeps this baby in the sky. Of course, there's much more contributing factors than just this angle. For example, to get a better understanding is this lift equation. You'll probably never see this. You'll never be in the sky, in the cockpit, and typing this mathematical formula because that's not what we do. But it's important to understand it because these are things that affect lift. For example, air density. Maybe it's hotter, maybe it's colder. That will affect how much we can lift. Maybe we're going faster, maybe we're not. These are things we can control, I can control how fast we're going, how slow we're going. That will later play into thrust, keep that in mind, And maybe we can control, how big the surface of the wing is. These are just contributing factors. But as we pilots have theorized, most science engineers, we've come across 2 principles, mainly Bernoulli's principle as a contributing factor to why lift is, because why does it lift, okay? Well, we have a thing called Bernoulli's principle. As the speed of a fluid increases, pressure decreases. So here, this speed over here is increasing faster and faster and faster. This is low pressure because its speed increases. Now we have low pressure here. And below here, we have high pressure. And high wants to go to low. And so as high goes to low, now we have this force pushing up on this aircraft, which creates our lift force. Very huge, a very huge deal, at least to understanding. Another contributing factor is Newton's 3rd law. For every action, there's an equal and opposite reaction. I've drawn this image for you here, and it's a guy punching another guy. Bam! And then guess what happens? The other guy punches him back. Bam! You know, every action has an equal and opposite reaction. So, as once again using this fake wing here that's having here, and there's this relative wing that hits it. Now we have an action that's, you know, causing this plane to hit up, and it's forcing the same plane, the same force to go down, which then is causing this force to go up, which is causing a lift force, because that's its reaction. And so that is how we cover lift. Now, what is the opposite of lift? Weight. Thank you for answering, class. Now, what is weight? Well, in its mathematical equation, weight is, hold on with me, class. Hold on with, weight is mass times gravity. And so, you know, mass is, you know, how much you weigh. You know, I'm 90 pounds of mass, and then gravity's pulling me down, and this is causing this weight force, this downward force, and that's contradicting to lift. And you never want to have, you know, too much weight, because then it'll overpower your lift and you'll never take off. And that's important to understanding the principles of flight. Now, let's go over the two other forces we have here. We have thrust. Now, what is thrust? How do we move forward? Well, that's a great question. We have these things, as we see here, a propeller. Now, what is a propeller? Well, the best way to think of a propeller is an upside down wing. And so these in their own right, as wind is going over them, are in itself creating a force that's making it move forward, thrust. And the propeller is also connected to an engine. And this engine is rotating and spinning and causing this forward motion. Now, what is the opposite of thrust, you may ask? Oh, great, it's drag. Here, let me clean up this board here so we can make some spaces. More talk about drag. But let's go back into why this is important, because these are the principles of flight. These are understanding the basics of the aircraft. That's why we have to know these forces, because without them, we're not understanding, you know, while we're in the plane, why is this going forward? If I do this, why is this doing this? You know, you never want to be asking yourself, you want to know why this is, why you're flying this plane. So there are two types of drag, to put it simply. We have parasite and induced. And induced is simply the byproduct of lift. That's right, that lifting force we were talking about. So as you lift more, the more drag you get. So that's something you want to consider in your principles, because, you know, you want to be able to move forward. You know, you never want to have too much drag, because then, you know, you're not moving at all, because these forces contradict each other. So then, you know, you want to also reduce your lift so you can reduce your induced drag, and so you can move faster, travel faster. That's important, because you want to go fast, and go as fast as possible. Not really, but, you know, let's get places. Parasite. So there are three things you want to, that parasite is broken down to. First, we have form drag. And this is just the shape of the aircraft. Oh, forget my drawing, I swear it's good. That's a good plane right there, that's a good plane. Form drag is the shape of this aircraft. Every aircraft have different shapes, and that can affect its different form. Its different form drag. Now we have interference drag. And this, I like to think of it like intersecting drag. You know, that's a good way to remember it. Intersecting, interference, intersecting. And this contributes because here in this aircraft that we just drew, I don't need to draw another one. See these corners here, these wedges? These are an intersection. And between that in itself creates drag like eddies, and that is another form of drag. Lastly, we have skin friction drag. And that's just the skin. Skin of the aircraft. My skin, airplane skin, you know, back in World War II, they used to oil up the planes, you know, so they can get better friction and move faster and of that nature, so they can have an advantage over their speed. And these are things you have to consider, you know, need to know, so you can understand these principles, manipulate them, and have a better advantage during flight. So again, say it with me, class, for the principles of flight, for the 4 forces that act on an aircraft are lift, weight, thrust, and drag. All right, get out there, pilots, go, go, go.